record the meeting. So, Brendan proposed there are some patterns for CRD. So I do believe for folks on the call, we should all like familiar with CRD and like TPR way before. I think what's interesting for us is that there's a compiler pattern that, and also operator pattern related to the compiler pattern proposed here. So basically, we can view CRD as sort of provide mapping from some of the customized definition of extended resources and map it to the low-level Kubernetes semantics. So I think what relates to us is we discussed the policy object way before. So say if we have like scheduling policy and authorization policy, those policy object available. So could like CRD be also the one that could map many of the extended resource definitions to all those policy objects, like for example, in the Gatekeeper project, right? Is there like a connection like that?
Well, for Gatekeeper v3, the new version, it's all CRDs. Is that your question, or?
Yeah. I was just like thinking loud. So in Gatekeeper we have. Let me try to remember. We have constraint controller, right? Data sync controllers, audit controller.
Yeah.
So those things basically maps like does it map like things defined from OPA to like Kubernetes semantics? Can we say that?
Yeah, so the constraint is, so what used to be config maps are now CRDs. So each constraint, each policy is a CRD object.
Mm-hmm.
And they get persisted to OPA. And as far as the data, it depends on how the cluster admin sets it up, but you can essentially pass what objects you want to persist into OPA.
I think another question is, so say if we have a scheduling policy object defined in the Kubernetes scheduler, what like how we like connect the scheduling policy object with the Gatekeeper side of things? Do you have any like initial thoughts?
I'm not familiar with this yet, so yeah, maybe let me read a little bit.
Or like let me try to think another way. So Gatekeeper. So Gatekeeper, in essence, provide like a way for user to manipulate, doing the, for example, audit policy in a Kubernetes way, right? And things could persist in OPA and checked by OPA. So I think one of my questions was like, if we have like policy objects defined within Kubernetes itself. Will gatekeeper also be a segue like for OPA semantics to be mapped to those policy objects defined in Kubernetes, or it's like totally different?
Are you referring to like?
For example, like a pod security policy.
Potentially, maybe, right? I think you're talking about could you use like the policies for Kubernetes itself, right?
Yeah.
Potentially. I think that's definitely one use case.
Okay, so that means if we want to write some rules for pod security policy in Regal, and then it could be like materialized in Gatekeeper, and then Gatekeeper could interact with the pod security policy side of things. Does that make sense, or?
Yeah, I think that definitely makes sense. I think some things to think about would be like one thing we start to look at like on the Gatekeeper project is like who's going to do this, right? Meaning like the people that create the policies are probably not the same people that are maintaining like say Gatekeeper, right? Like they should have different roles and permissions. Does that make sense?
Yeah. Okay, that's interesting. So that means basically the CRD mechanism could also like provide the compiler, or we have an operator framework. So providing this compiler functionality, in this case, Gatekeeper for Kubernetes policy itself, right?
Right.
So Gatekeeper compiles the Regal semantics from OPA to the Kubernetes semantics.
Right.
Right, in essence. Cool. Erica, any thoughts on this?
I'm still creating thoughts. Don't have a coherent question right now.
Okay. I think we can move forward.
And you guys know about the meeting we have, the Gatekeeper meeting we have on Tuesdays? If not, maybe you can join. I think, especially because we're designing, like writing V3, and a lot of things we're looking for user feedback. So,
could you add a link to the meeting notes somewhere, maybe?
I think, yeah. We had Gatekeeper folks came up before, but yeah, I don't think we have the meeting information. Okay, cool. So next one is something I stumbled over earlier this week. Very, very interesting. So there's a UN group. I didn't ever expect to read anything from UN. So there's a UN group working on privacy, basically folks from different companies related to crypto and privacy solutions. Do check out this handbook. It's super awesome. Many of the introductory stuff, and I haven't read it all, but it just looked awesome to me. So one of the things they talked about is the policy enforcement for a privacy preserving system. So is also quite interesting. So you mentioned that the policy decision points process these rules into machine readable form with policy enforcement point provide technical means to assure that rules are followed. So I think what that means is that I think what we do here is, so for stuff like MPC, homomorphic encryption, differential privacy, ZK proofs, those stuff could also like be applied for a policy system. Ah, here we go. There's this awesome figure. I think the policy enforcement they mentioned here mostly are like human level policy stuff, but I do think this could like also be implemented on the system level that we are discussing. So this also like in line with what Robert mentioned last week regarding TEE. So I think, yeah, we discussed a little bit about the enclave. So I think this will be like another area could be super interesting for us to check out. Okay, any thoughts?
This looks pretty cool.
Yeah.
It's interesting also to see how much stuff there is outside of our little small domain, people working on related things.
Yeah, this handbook is just awesome. Do check out. We might have some like new thoughts. And so I was listening to the Zero Knowledge FM podcast the other day. So they had the episode on formal verification, very informative as well. So I learned the K framework. Let me find it. There's a slide. Yeah, so K framework is basically a tool for like formal verification for languages. I think a lot of projects, especially blockchain related projects, looking forward for K-frame to do the formal verification. So there's a website I think you guys could check out later. I'm not expert on this area. What interesting to me is what mentioned in the episode is that AWS actually have been doing the formal verification. Well, I didn't know that. So AWS has been doing formal verification for their web services since really early on, like starting from 2011. They formed a group called Automated Reasoning Group in 2014. The stuff just mind-blowing. So it was headed by Brian Cook. So I was checking out yesterday about all the materials about formal reasoning. So I think you guys could check it out as well. It's very like
I'm super excited about formal methods.
Super interesting.
But so now that you're telling me that I can bring in this into policy work too, has me very excited.
Yeah, I never thought about this in this way, right? So formal verification, I used to like think this is something used on hardware, like you when you do synthesization or on hardware or on software, but mostly related to, if you're building blockchain, you have to know all these little virtual machines that your language could do, something like that. But knowing we can do this in a cloud system is just super exciting. There are some papers I do recommend. Like this is the one. I actually follow one of the author, Mark Brooker, super cool
Yeah.
guy on distributed system on Twitter. I think
What's amazing is like TLA plus is Leslie Lamport's thing.
Yeah.
And for instance, the raft, the algorithm is defined in it and shown that it meets the properties it needs. And there's an issue open on etcd to make the model in TLA plus.
Oh, really?
But no one has gotten around to it. It's also been used like in DynamoDB and CosmoDB and other things.
Yeah.
So bringing it into Kubernetes and formally, I think would be really great.
Yeah. Another caveat, really interesting thing is that the original paper was hosted by Lamport on the Azure site for a Amazon service. It's just amazing how collaboration go across. So do check out the awesome videos and papers. So all that stuff came around, and to me is a figure like that. I think we finally had something, a holistic architecture we have been looking for. 20%. So we have been like, since we know OPA and policy well, so I think we have been focused on the policy engine side before. Now, if we think about, we have compiler patterns, and also if we bring in verification, formal verification, I think this could be the holistic picture. Say if we have a correct policy object as a type system defined in the control plane, defined in the data plane, then we have the policy engine basically could do the verification in a just-in-time style. We could have the formal verification do checking things like sort of ahead of time. I do believe they also at least AWS also have this concept of continuous formal verification. So this could be also applied in runtime. And we have compiler basically provide like mappings from like policy engine like OPA to the policy semantics we define in Kubernetes or Istio or whatever. So I think these things putting together actually could make sense of a whole policy system.
Before we lose people though, what are the practical steps?
I think we could just bring one of the example that the AWS formal verification they usually talk about, like if you have, say, Kubernetes tenant, right? That the tenant is something like financial, say like Goldman Sachs or whatever. They will have very strict rules about like separation, and also they have to do PCI compliant, right? All those stuff, which means it would be like practically very difficult for them to build up a correct sort of a correct system building upon Kubernetes. So that's where you have OPA as the policy engine, so they can write policy rules in a declarative way, like networking, who should not talk to what, certain users will never be allowed to certain like ports, stuff like that. And also PCI, so PCI regulates a lot of stuff on networking and data, right? So you have the compiler, in this case, will be the gatekeeper to translate all these OPA rules into semantics that Kubernetes could implement. And also, if we have a formal a verification engine that could do the formal verification of like the entire Kubernetes system, at least on the policy side. So we check if there's like any bugs in the policy system, we could check it like ahead of time using the verification engine. And then we can have policy engines like sort of in the runtime keep checking like the user defined policy, if it is like in violation of the system policy or in violation of some of the admin policy defined before. Does it make sense?
Makes sense. Let's break this up some more.
Yeah. So a thought related to this, do you guys think it would be a good idea that we like ask TOC to see if like do we have a way collaborate with like universities doing like long-term research for this stuff, since this not like purely development stuff, right? We kind of need some of the theoretic framework.
We can ask in the safe working group a little, since some of those have research contacts. And then we could, I know, for instance, there was like some Berkeley researchers who were like wanted to contribute a scheduler or something. So there's definitely been those collaborations. I don't know that there's any like formal things set up for it.
I think I'm also gonna just email Brian to try my luck. Yeah, if he's interested. I don't think anyone like brings about like formal verification, all that stuff with Kubernetes before, right? I could be wrong, but
nothing that I've seen.
Yeah, it could be, well, very, very tedious and hard work, but it will be really interesting for us. Okay, any thoughts from like Rita, Patrick? Does this make sense?
Yeah, that's definitely interesting stuff.
Cool. Well, I run all of my rambling points. Erica, did you add the runtime class?
I did. I added that after this afternoon's discussion in SIG-Auth.
Okay. Can you?
As I understand it, runtime class is about that there's different runtimes, such as like gvisor or Windows containers, the regular kind of container D, and these have different features that they support.
Mm-hmm.
So once pods can specify which runtimes that they support, how do you validate things where not all fields on a pod are valid necessarily, or where policies might change based on the runtime? So that was the conversation.
Is there a way like today, or there's nothing yet?
Tim's writing up some gaps.
Okay, cool. Sounds like really cool stuff. So basically, they want to tweak policy on these different runtime classes, right?
Sort of. I think this is just the latest example, sort of where they aren't sure where to take pod security policies, as well as, is a pod, or what does that mean? Those first couple of KEPs. So I don't think they had any answers, but.
So do we have some initial thoughts for them, or? Well, first of all, does this runtime have a way to for the policy enforcement, or we kind of have to trick it through like CRIO, cryo?
I don't. No.
Yeah, another question. So during the Istio talk, so they mentioned they are defining the authorization policy. Do we have stuff like that? The team didn't reply to me on the email later. So, do we have like stuff like authorization policy from CGOth? I don't think so, right?
Authorization policy. There's like RBAC, which is sort of that, right?
Yeah, like a single object, like a standalone policy object. Do we have something like that?
I don't think so.
Right? Yeah, that's what I thought. Do you know if Yasin's still working on the scheduling policy proposal? Because this KEP seems like expired.
He just pinged me today. I was gonna follow up and see where that is. I think Tim said something about 115. But also 115. There's the maybe is scheduling policy a place like do we want it, or would something out of tree closer to like gatekeeper be better? There's still all of those ongoing discussions, I think.
Okay.
And no one with, I guess, the like need to make a quick decision and therefore rush it.
Okay. One time. Okay. Anything else? If not, I think we can have Lance talk a little bit on the OpenStack Keystone. So it's basically the OpenStack IAM system. There's a lot of pausing code up there. I think he was one of the project lead. So he can introduce like the policy side of things.
Sure. Are there specific questions that you guys have about it, or to be fair, I'm still like trying to wrap my head around some of the Kubernetes stuff. So some of the associations that I make aren't quite on. I apologize.
I think you can, let me just stop share. Can you share the screen? So I think you can just give a quick overview and then see if anyone has any questions.
Of just like Keystone in general, or how policy specifically works?
Yeah.
I think I'm interested in what the model for policy is, how well it's worked for the project and for end users.
Sure, those are great questions. So to kind of preface this a little bit, I'm not sure how many other people on the call have experience with OpenStack or kind of like where it came from, but we kind of had some issues with how fast some of the APIs grew. And if I were to sum it up, the API development and features and functionality that kind of got pushed into the various services outpaced the way that we could develop a policy engine to support it, if that makes sense. So for example,
that makes sense.
Like, you know, in like Kubernetes, you have cluster roles, which are kind of like, correct me if I'm wrong, but like system, like operator specific things, right?
They're like global policies. Yeah.
So like things that only like infrastructure admins should be tinkering with, right?
Close. I don't want to, at least in combination with cluster role bindings.
Okay, cool. Up till recently, like we didn't really have something for that in OpenStack, yet we had a whole bunch of different APIs that would modify system level resources or like compute hypervisors or things like that. So one of the patterns that we're currently trying to correct is reusing or rewriting some of those APIs to be protected underneath a different construct, which is similar to like the cluster role or cluster role bindings that Kubernetes uses, where it's like a separate target. And I think that that's be a really good thing moving forward, because I think that from a user perspective, you have a lot of people who kind of, they see that they have the administrator role on a project or a tenant or a namespace, right? And then all of a sudden they start looking at the things that they can do and they're like, oh, wow, I can roll up my own service. Like I can see hypervisor information or XYZ, right? And that's kind of like a scary thing from a tenancy perspective. So a lot of what we've been working on over the last 2 years or so has been introducing the concepts and plumbing and tooling to make it easier for developers to write policies that fit a better security model by default, if that makes sense. I hope I didn't like lose anybody there in that, and feel free to slow me down, or if this is all like old news to you guys, just let me know.
This is good for me.
Cool. I guess how it works, like if you were to be curious about the implementation, everything kind of comes out of what Howard said as like our IAM solution, which is Keystone. And that's where we do like the user management that either backs to LDAP, or if you have something else that is like an identity provider that issues SAML assertions or something like that, like you can exchange those assertions or credentials for tokens that have roles associated to them that are namespace to a project. And then you can go talk to a service and say, hey, I need a VM, or I need a block storage device or something. So all of the lifeblood of what things are associated to essentially come from that token. And that's kind of where some of the issues with how we kind of outgrew our original policy engine kind of came into play, because we were reusing a lot of like namespace specific concepts or tenant specific concepts to protect things that didn't really belong in a tenant or a namespace or a project. But all of that stuff kind of gets enforced at the service. And if you're familiar, with like the OpenStack project structure, all the APIs live across different repositories, and kind of wrangling that has been tough just because everything kind of grew really fast. So like wrangling that back into something that is consistent across like 50 repos is a pretty big challenge. But eventually I think it'll get there. It's a lot of work to kind of go clean up, and like parsing how all of it works in each different project is kind of a bear, but
so most policies though are kind of handled by the individual project components rather than say pushed off onto the user.
Kind of, yeah. So if you are, let's say you're a developer and you're writing a new API for a service, you have the ability to protect that API with a policy, and then that policy is kind of like shipped with a default, and then those defaults can be overridden by operators through an override file that they can supply to the service that says, I don't want to use the default policies. I have my own security model that I need to adhere to. Instead, I would like you to use these.
So besides the multiple like repos and just decentralized projects, what have been some of the largest pain points, and what has worked particularly well that you would encourage others to use?
So some of the pain points, I guess, that I've already kind of highlighted, but like I can touch on it again, would be there was no real centralized vision for what I think people wanted policy to be. So like when people were writing all these APIs and we started introducing APIs into OpenStack that controlled things underneath VMs or like the actual infrastructure or the network infrastructure or whatever, there was no real good, like consistent way to make sure that that was targeted for system administrators and not like project administrators or somebody who might be a customer and they have their own like project that they're doing things in, right? That because that was really blurry, it kind of made things really tough to secure for operators. But because things were overridable, it gave operators a way to kind of work around the issue. So I guess that's good. That's a little bit of a double-edged sword. So it's a good question, or the good thing that you brought up, because a lot of people say like why is policy customizable? You shouldn't be able to customize something and open up holes in your API. But in a way, like it at least allowed us to kind of like suggest better policies, at least until we could get the plumbing in place to introduce like a first class construct for system specific API protection. and get all of that pushed through the various libraries and get that propagated out to some of the other services, if that makes sense. Another big tough thing I guess we had was like standardizing on roles, because like with all of it being spread across various projects, one service might say like, well, we have this auditor role that is doing like read-only specific things. And then in another service, they might call it like reader or observer, right? So when you start going through and like reading the code for all these different services and kind of trying to figure out how they are specifically using policy, you kind of start to come up with these like the same patterns. It's just they're all slightly inconsistent. So that was kind of like another interesting thing to kind of wrangle. So we really needed like the tooling to do like formal deprecations. That was a really, really big important thing for policy, just because up to like, I think it was probably 2.5, 3 years ago, we didn't really have a way to say like this policy is deprecated by default. We urge you to use this instead. So once we had that in place, we could really start looking at ways that we can improve and like move towards a consistent set of policies instead of everyone kind of doing their own thing, which made things really tough for operators because they're like, oh, well, I've got to use this specific role for this service to do read-only things, but I've got to use a different role name to do read-only things in this service or something, right? It's just another, like a mental hurdle that they have to, another mental mapping that they have to keep track of that isn't really necessary in our opinion, I guess. I don't know if that answers your question or not.
Yeah, no, it's really interesting, especially with the Kubernetes move to CRDs and other for APIs. It means the ability to add APIs is not controlled by the project. It's dynamic and depends on people's clusters and what sort of system they're running and have it configured, which makes this problem even harder. And maybe we just haven't run into it yet in some aspects.
Sure. So this might be a dumb question, but so in Kubernetes, like CRDs and stuff, that's all controlled by like the person setting up the cluster, right?
Usually.
Okay.
They are global objects, but there's a bit of more dynamic things where you have, because you kind of have packages that you would install that might contain a CRD to install the operator. So while a cluster admin would do that, most likely they might only want to do it sort of on demand or as needed. And there's talk about if they would like that to be able to be different per kind of project. So yeah, we've gotten through a little bit by just saying it's the cluster administrator, but that's maybe not totally accurate to where things are moving, if that makes sense.
Interesting. Cool.
Has there any progress with like Congress working with Keystone or?
That's always been a really interesting question, because we kind of have like a chicken and egg problem with how like you have role bindings and things like that in Keystone, and then users go talk to Congress, and then Congress has to validate their role bindings and so on and so forth. So there hasn't been a ton of integration between Congress and Keystone specifically. Keystone's domain is still very much like you have a target, or you have an actor, like a user or a group, and they have assignments on targets, which could be the deployment system, which is kind of like the cluster, and domains and projects. So Keystone's like sole responsibility, and from an assignment perspective, kind of lives within that space. And it sounds like Congress does stuff that's much more rich, but not like a ton of integration between the two, kind of because there's the whole chicken and egg.
Yeah. So for those of you didn't know the history, Congress was like before life of OPA. It is sort of like the predecessor of like Gatekeeper. So I knew Tim since he was in the OpenStack Congress days. They were using Datalog to describe the policies, and they initiate the Congress project. And then later on, Kubernetes came out. They initiate the OPA project, and then we have Gatekeeper now. It's just a bit of interesting history here.
Yeah, so is there something we can learn, or is it we are doomed to never have a complete...
I think the only takeaway, at least from my side, is policy is hard. It's really hard. When they use Datalog, they were like criticized. Well, not criticized, but I think people complain that Datalog is really difficult to like describe policy. I think with Rego now, I don't think how folks like Rita perceives Rego. I think it might be a little bit better than manipulating Datalog stuff, but still, I think it's just super hard to do policy language. Not to mention, if we involve like formal verification, that means we're gonna write a bunch of stuff that I think 90% of people won't understand. It's just hard to introduce this in the cloud services.
Interesting.
Yeah, so this was like, how many years? At least 4 or 5 years ago. Yeah, those people it came a long way to introducing policy into cloud computing.
Has anyone made any kind of like cross compilation between Rego and Datalog?
I don't think so, but if you bring this up to Tim, I think he will be like tears in his eyes and super interested. Okay, any other question regarding like infrastructure policy?
Does OpenStack have any sort of formal verifications or other checks?
That's a good question. We have a testing plugin called Patrol, and that's like it's integrated into our gate, and it's supposed to kind of verify. They're trying to do the whole verification problem too, and that's a tough thing that they're like working through. I think that was driven by a bunch of folks at AT&T for a while. But their goal is essentially to have like a series of checks to verify a policy or a set of policies. So like if you have an OpenStack deployment running somewhere, take these take this set of patrol tests and run it against this set of APIs. And if it comes back green, then you know that you haven't opened up any like holes in your API. Or another use case was like if I need to like roll my own custom policy because I've got to meet these specific like security requirements, I would like to have a tool for verifying that it works, or like some sort of standardized thing.
So anyone brings up like if we use, for example, Terraform on top of OpenStack, Terraform also have this policy encode mechanism, right? Sentinel, how to pronounce that? So anybody like brings up the question like, is there any correlations between like policy in Terraform and policy in Keystone? Lens?
Not that I'm entirely aware of. I would need to go dig.
Okay. So Patrol is part of Tempest? Yeah, Tempest plugin.
Yeah, it's a plugin that essentially just is purely focused on protection testing.
I think there's an open issue that was kind of mentioned and quickly kind of grumble dismissed about some kind of RBAC testing in Kubernetes.
Did that get brought up today in the meeting?
I thought it was like very quickly and then kind of like brushed past.
Yeah, it's a tough thing. Like it gets like, I know with Patrol, one of the things that they've always kind of been like not shy of, but one thing that they're aware of is like how expensive it is to like test all of these different permutations on all these APIs across all these different services. And I know it's like a topic that comes up often whenever there's a face-to-face gathering.
That's one of the things that, at least looking into, I think some of the older formal verification tooling might help with, since they kind of dealt with similar problems. I think there are various techniques. Obviously, you can't fully enumerate the state space.
Right. I guess one thing that we just started doing within the last year, and this kind of has a little bit of overlap with some of the stuff that Patrol verifies, but it's kept in project, is just like functional testing that tests the APIs, but we're only testing against like a known set of defaults. So we have like 3 roles that come out of the box, and then we're testing those 3 roles against the 3 different scopes that are available. So you have 9 different permutations to test for, which is still a lot, but that's something that some of the services are like moving towards as they want to start refactoring how their policy enforcement is done, because it might be like sprinkled between the API layer and then through other components. A lot of services want to like consolidate that into a single like layer, so that it's easier to understand and all that kind of stuff. But before they want to like make that refactor happen, they're starting to like write all these different API tests to make sure that if they change something, how the policy is tested or how the policy is enforced, they catch it in tests. Because we've had a few cases like where we go to start doing some of these refactors around this like super old part of the code base, like something breaks and then we don't catch it until like an operator catches it. So that's always been like a really tough thing for us to do too. But
it's cool. I'm really glad got to hear it and talk, since it's interesting if more than one project, and I'm sure there probably are more, dealing with similar problems. Hopefully maybe we could help each other out if anyone gets somewhere.
Yeah, absolutely. I know I've been trying to wrap my head around how to write all these tests in a way that's dry, but, doesn't take forever. And, eventually the system will probably need to evolve again. Like we're spending all this time, trying to fix stuff and clean things up. And, right now we're thinking, oh, this is going to be great. Like as soon as it's done, it's done. But, in a few years, something might happen and, be like, oh, well, we should have planned for this case or something, and we'll need to refactor it again. So trying to come up with a perfect mix of having it be flexible yet dry and still be able to run in a reasonable amount of time is the perfect storm of a hard problem for us right now. And I assume there's plenty of other people who've thought about the problem or maybe have made better progress on it than we have.
I don't know that the Kubernetes project has, perhaps inside other enterprises or things, but
Okay, any other question? Okay, I think we've run through all the items on the agenda today. I think I can so I can follow up with the email to TOC and maybe add something to the SAFE working group meeting. But since it's just way too early for China, I think Erica, if you attend the meeting, you can brought it up
I'll be able
about
to
the
go.
long-term research. How
If you want to put anything under in the SAFE working group notes, they usually have a holder for Kubernetes. You can add some points.
Okay. Okay. Thank you so much. Oh, Rita, please add the gatekeeper meeting information on the meeting.
Yeah, I added it to the top. Maybe it might be in the wrong place, but
where is it? Is
right there.
Yeah, got it. Yeah. Thank you so much. Okay, folks, thank you for attending the meeting. Let's meet next week.
That was good. Thanks, Howard.
Thank you.
Awesome.
Bye-bye.
Thank you, everyone.
Yep. Take care.